Hello, geometry students. Welcome back. In a previous lesson, we recently learned about polygons. Polygons are figures that are closed. They could be convex or concave, and they have a certain number of sides. Later, we talked about three-sided, the simplest kind of polygons, the triangle. We learned properties of triangles and different ways of classifying triangles. In this lesson, we're going to do much the same thing as we did in that triangle lesson, except now we've graduated to four-sided figures. We're going to be talking about quadrilaterals, polygons with four sides. Now, as we talk about quadrilaterals, first of all, we're going to talk about the different ways that those four sides can be arranged to make different shapes of quadrilaterals. One of those ways is by arranging it into a parallelogram. I'll talk about what that is in just a moment. But I'm bringing up parallelograms now because I want to mention, after we talk about the different arrangements of sides, we're going to say that there's three special kinds of parallelograms, three specific kinds that we encounter in everyday life. I would say that the parallelogram is probably the most encountered quadrilateral. We just see it all over the place. We use it for all sorts of different things. But yeah, then we're going to work some practice problems. Let's get started on the actual lesson here as we talk about what a parallelogram is. Now, a parallelogram is a figure that has four sides, quadrilateral, and the opposite pairs of sides are parallel. So it has one pair of parallel sides and another pair of parallel sides. Who knew that parallels would be important to a parallelogram? All right, but just keep in mind, you can't have adjacent sides that are parallel. What would that even mean if adjacent sides were parallel? So it has to be opposite sides. And the only thing that really qualifies a quadrilateral to be a parallelogram, all it needs is to have parallel opposite sides. Two pairs of parallel opposite sides. That's a parallelogram. What's another arrangement that we can come up with for a quadrilateral? Well, instead of talking about parallel sides, what if I talk about congruent sides? A kite is a quadrilateral that has two pairs of congruent sides, and those congruent sides are adjacent to each other. So here I have one pair of congruent adjacent sides, and then on the bottom there's another pair. Why does this take on the shape of a kite? You would call this a kite shape. The reason it does that is because one of the pairs of sides is going to be longer than the other pairs of sides. There's still going to be congruent consecutive sides, but because we're going to have one longer pair, that longer pair is always going to look like the bottom of a kite, and then the shorter pair will look like the top of a kite. Another type of four-sided figure is a trapezoid that has exactly one pair of opposite sides. Now notice in kite and in trapezoid, we have that word exactly. That's a really important word in geometry. That means that we're going to have, when it says exactly one, there can't be two or three. There can only be one to meet the definition. So for a kite, we have to have exactly two pairs of consecutive congruent sides. For a trapezoid, we can only have one pair of opposite sides that are parallel. If there are two pairs of opposite sides, so if the definition was just one pair instead of exactly one pair of opposite sides that are parallel, then a parallelogram would be a type of trapezoid, but that's not what it says. It says we have exactly one pair of opposite parallel sides. That makes this a trapezoid. Now, it doesn't matter if these angles on the bottom are congruent or not. This would be a trapezoid simply as long as it has parallel opposite sides. And then lastly, my favorite shape, the trapezium. It's a quadrilateral that has no parallel sides. So if none of the sides are parallel, it's interesting to think, can any of the sides be congruent? Interesting to think about these quadrilaterals. All right, now let's talk about our three specific types of parallelograms. Our first type is a rectangle. A rectangle is a type of parallelogram, but not all parallelograms are rectangles, okay? A rectangle is a special parallelogram that has four right angles. Four angles, each of them 90 degrees. A rhombus is a parallelogram with four congruent sides. Now notice the sides are congruent, but also the opposite sides are parallel in a figure that has 4 congruent sides. In fact, anytime a figure has 4 congruent sides, the opposite sides have to be parallel. There's no other way to arrange it. And then, if we have both of these situations going on, if we have 4 right angles and if we have 4 congruent sides, we have a square. It's a parallelogram that has both 4 right angles and 4 congruent sides. Notice that a square is a type of rectangle, and a square is a type of rhombus. It meets both definitions. It has 4 right angles. It has 4 congruent sides. But just because a square is a type of rhombus doesn't mean that all rhombi are squares, right? And just because a square is a type of rectangle does not mean that all rectangles are squares. Squares are a special case of that are a cross between a rhombus and a rectangle, a robtangle. A romtangle? I don't know. All right, let's take a look at some practice problems related to these 4-sided shapes. Letter A, classify this quadrilateral, give multiple names if possible. Okay, so I can see in this quadrilateral we have 2 pairs of parallel opposite sides. That makes this a parallelogram. I also see, as I look at my types of parallelograms, first of all, it doesn't have right angles, so rectangle and square are out, but is it a rhombus? It has to be a rhombus because the 4 sides are all congruent. So I would classify this as a parallelogram and a rhombus. Letter B, in quadrilateral PQRS. Okay, we're not given a picture of PQRS. In fact, we have to sketch it. PQ is parallel to RS. PS is parallel to QR. Also, PQ is approximately twice as long as QR. Sketch PQRS. Well, I would sketch it like this. And I didn't actually put on my points, but I would put them at the corners, P, Q, R, S. They have to go in consecutive order as labeled. I couldn't go P, Q, R, S. So let me go ahead and we'll label the corners of this figure, and then we'll identify what kind of figure this is. Okay, so here's P up in the upper left. Now notice that because I have 2 pairs of opposite parallel sides, this figure has to be some kind of parallelogram. Is it one of the special types of parallelograms? Well, it doesn't have 4 right angles, so it can't be a rectangle or a square. And in addition to that, it doesn't have 4 congruent sides, so it can't be a rhombus. So this is no special type of parallelogram. It's just your everyday run-of-the-mill parallelogram as a shape. PQRS. All right. Let's move on to letter C. An Olympic swimming pool is a rectangle measuring 25 meters by 50 meters. Find its perimeter and area. Well, to find the perimeter, I'm just going to multiply 2 sides times 25 meters plus 2 sides times 50 meters. Or I could do 25 plus 25 plus 50 plus 50. Perimeter is easy. Okay, it's going to be 150 meters. Area is not hard either. Area is just going to be base times height, 25 times 50. Really simply, 25 times 50 is 1,250, and in this case it's in meters, so I'm going to write meters squared as my label. Now, what about this square? First of all, is this even a square? It looks pretty diagonal to me. Well, yes. Even if you rotate a square so it's diagonal, it is still a square. Let's see if we can determine its area. Well, I know one of the sides is 4.3, and that means that all of the sides are 4.3. And to find the area of a figure, of a square, I just multiply base times the other base, or side times side, or side squared. So actually all I have to do here is take 4.3 squared to find the area. But first, before we find the area, I forgot, we're doing perimeter first. So perimeter is just 4 times 4.3 because all the sides are the same length. 4 times 4.3 is 17.2. And then 4.3 squared to find the area is 18.49 centimeters squared. If this seemed like an easy lesson, this is an easy lesson. It's easy.